This is exam paper 2021, paper 1, question 5. It's a 30-mark question and it's involved in the topic of calculus. So it says the derivative of f of x equals to this. Perfect. It's a cubic. And it says the derivative can be expressed in the form f dash x, so the derivative, f dash x equals to a x plus b squared plus c, where a, b and c are an element of z and x is an element of r. It says find the value of a, the value of b and the value of c. Now, for me, when I look at this straight away, first thing I'm going to get is the derivative of that. So that's a fairly straightforward differentiation. So we'll do that now in a second. And once we get that, this jumps out as me as well. This jumps out at me as this looks like a completed square. Now, it's not the only way to do it, but that's the way that I'm going to do it here, simply because they've given you a first derivative. And when you have a first derivative, the cubic becomes a quadratic, and we can complete the square of that, and that jumps out as me there. Okay, the examiners use that a couple of times over the last number of years. That's the way I'm going to do it. So if I want to find the first derivative of f dash x, what am I going to do? Well, you might recall, just take each one of these as they come. So take the power and multiply by the number in front, drop the power by 1. Grand, take the power, multiply by the number in front, drop the power by 1. Take the power, multiply by the number in front, drop the power by 1. X to the power of 0 is just 1, so minus 12 times 1 is minus 12. A lot of you guys will probably just learn that as the x disappears and the number just gone, irrelevant. So the first derivative is this here. Now, what I'm going to do is I'm going to complete the square of that there. I cannot complete the square as is if there is a number in front. I can't cancel because it's not a proper equation or anything yet. So what I have to do is the highest common factor. Now, if I take the sixth of anything in front of this x squared, I can't complete the square. So if that was a minus or any sort of number, I'd take that outside a bracket here. And yes, it's brilliant that it goes into all these numbers. 6 into 6x squared is x squared. We've got plus 2x minus 2. It doesn't always go in like that. Sometimes you've got decimals and fractions. It's just something to be aware of. So what I'm going to do is I'm going to complete the square of what's inside this bracket here. Leave the 6 on the outside. That will be sorted out in a while. Many different ways of doing this. If you know the shortcut, you don't have to do it the way I'm doing here. That's fine. What I'm going to do is write the first two things down exactly as they are. I halve the number in front of x, which gives me 1. I square it, so 1 squared is 1, and I add it on. I then subtract the number I've just added on, so I added 1, subtracted 1, and then take down my final digit, and I should be left with 5 terms. And if you look at it, yes, it looks strange, but this value here is the exact same as this value here. It'd be like taking your age, adding 5, and subtracting 5. It doesn't do anything. But what it does do for us is, if you've done this correctly, those first 3 terms are always going to be a perfect square, all the time. And you can factorize them as a quadratic. Both factors will be the same, so therefore you can make it into a square. Or you can do a little bit of a shortcut, because sometimes it's harder to actually factorize if there's decimals and fractions and stuff. So I know when I factorize this, there'll be 2 factors, and the 2 brackets there will be the exact same. So I know without a shadow of a doubt, when I put them together, I'll have x and something squared. I can fill this number out here by just taking half the number in front of this x. So I've just turned that blue line, the stuff in that blue line, into this thing here. And I just add these 2 together in my calculator. In this case, it's fairly straightforward. So we've got minus 3. Now, we're not finished yet. The reason we're not finished yet is because they asked for it in this format here, without the outside bracket. So what we have to do, and this causes a lot of contention, is we got to multiply 6 by this, and we got to multiply 6 by this. When we do, it looks like I don't multiply by the first one, but I do. You'll see the outside bracket is actually removed, so we've got 6 times x plus 1 squared minus 18. So what I have done now is I've completed the square, and now what I can do is just compare this to this. So we can see that A very clearly is 6, we can see that B very clearly is 1, and we can see that C very clearly is minus 18. Some people will be a little bit scared because that says plus C and that says minus 18, but they've taken care of that in the question by saying X is an element of A, B and C are an element of Z, so they can be positive or negative whole numbers. In terms of the marks going for this, we've got 10 marks overall. Any correct differentiation whatsoever got you 3 marks, so we did more than that. If your differentiation was fully correct, you got the 5 marks. So for this line here, you got high partial credit if you identified any 2 of A, B or C correctly, so any 2 whatsoever, or you got to this here, so that got you 8 marks, and then you had 10 overall when you found out what your A, B and C are. So this is the 2021 Paper 1 Question 5, 30 mark calculus question, and we're on A Part 2. And what they've told us in A Part 2, they said if g of x equals to 36x plus 5, find the range of values for which the first derivative of f or f dash x is greater than g dash x. So quite similar to the last question, we've got to find stuff out before we actually attempt the question itself. Because they've told me that g of x is equal to 36x plus 5. So if I differentiate that to get their g of x there, that's very quickly just 36, because we drop the power down in front, drop the power by 1, and then the number just goes away. So that gives me that there. Now, if I'm trying to find out, like they said in the question, f dash x greater than g dash x, or the first derivative of each, I actually have what this is, and I have what this is from the previous part of the question. So all I'm going to do, like any equation or anything before, is just fill it in, and then see where it takes us. So if I fill in for this here, we have 6x squared plus 12x minus 12, and that's greater than 36. Okay, it says find the range of values for x, and now this is just a typical inequality. So it's nice the way they've brought this maths together for us. Well, I think that maybe you don't think it is, but it's nice the way they've done that. So we've got an inequality inside this. So what we do is, I'm going to treat it as if it's just a completely normal quadratic. Okay, so I know it's different because it's an inequality, but what I can do here is divide across by 6. Divide across by 6, and then what I can do is just solve the quadratic as normal. That won't be my answer, but they will be what's called critical values. So when I solve this here, we're looking for factors of 8 that give us plus 2, and if we put the factors equal to 0, we get x equals to minus 4, x equals to 2. Now that's not our answer, because we got to turn this back into inequalities, and there's loads of different ways of looking at it. Probably the most famous way, or the way that most of you guys would have done it in school, is to graph this quadratic. Okay, so that's the way that I'm going to look at it here, simply because that's the way I've seen most students use that. So we know this here is minus 4, we know this here is 2, because they're the roots, but in this case called the critical values. And we're looking for where is the quadratic greater than 0. So we're looking for this here. So that line there, those dashes in the line, previously if you've sketched this out, sometimes you get full marks for this, but not in the last number of years. But what that indicates is our actual solutions. That's what x is, that's what x is. So x is to the left of minus 4, so x is less than minus 4, and x is to the right of 2, so x is greater than 2. Doesn't matter which way you have it around, as long as the inequality is obviously facing the right way, and that's our answer. What some people would do is they might put a union in between here to show that it's 2 lists of numbers. All the numbers less than minus 4 forever, all the numbers greater than 2 forever, whatever suits you. And if you have a different way of filling that out, again, that is completely fine. It's 10 marks overall. Okay, so 10 marks overall. You got low partial credits for any correct differentiation of the gx, so that was 3 marks. You got mid partial credit if you correctly formed your inequality, so that was 5 marks. You got up to 8 marks out of 10 if you got the roots of the quadratic, but you always got to be careful when there's an inequality. That's not acceptable for full marks. We got to find some way to finish it off. In this case, we used the quadratic graph and then read it off that. So 10 marks overall.